what's the field here? You have a pair of equal charges, equal and opposite charges where, at this location, what the field is. That's the second example in the book, 14.4. I go through that quickly. That is so easy. Because it's one dimension, right?
Yes.
Not two dimension. One dimension is always easy. All right, so let me draw the picture again. You have a positive charge, you have a negative charge, and then you are asking at position P what the field is. This is Q, this is negative Q. See, this distance is A. And we need one more parameter, for example, how far this position is to a particular position. But I don't like to measure the distance this way. I want to measure the distance from the central point. Therefore, I define this distance as R.
Wait, so
2. Your picture looks very different than the picture in the book.
It's fine. Same story.
just have the y-axis.
Okay, so this distance.
Or, if you don't like this way, that's fine. You can define differently. For example, this is B. Okay, let's go this way.
I like R.
Yeah.
I just didn't know why.
This assignment said you are the boss.
Oh.
You are the boss. You see, you make a rule, everybody follows, right? So, okay.
So you just picked a random point between the two cubes.
No. This is the middle point between them.
And
Where
we
does
got
it say
A.
that?
Remember, we had A from the other one.
Because this is the center of this pair. It's more convenient.
Oh, I get what we're doing. Okay.
So it's more convenient. That's why I don't do this one. And I said this is R.
Yes, the y.
Therefore, you still can label this part. What is this part? If this is R, this is A. What's this?
No.
B.
No? You have to label
R,
this
R,
distance
R,
by
R,
R and A,
R
right?
minus 1/2 A.
Yeah, R minus.
Oh, very good. R minus 1/2 A. Yes.
You knew that, Kevin.
I forgot the 1/2. I got R minus A.
Now, the number is not 14.3.4. Okay, now we need to do the free body diagram, which is position P, right? There are two fields acting on that position. One field is produced by capital Q positive. What's the direction of that field at this location? You put a positive test charge, they will
Yes.
repel each other. Therefore, you have E positive Q, this direction, right?
Which point is that? The point we just,
This point.
that's what you just drew down there?
Yeah.
This charge produces a field at this location. The direction is, when you put a positive test charge here, they will repel each other. Therefore, the field over here goes the direction of the force, right? And look at this charge. This is the negative charge. It will produce another field at this location. What's the direction of the field?
Negative.
You put a positive charge here, this one will attract it, right? Therefore, the other field goes this direction, which is from the negative Q, right? You see, I don't even need to change anything here. The first two lines, that's still this. still this, but what's the angle of theta?
Is 90 is 1,
Not 90.
is
Initially you are here, now you go this way.
The
The
180.
angle becomes smaller, smaller, finally a line.
180.
0. 0.
So
Okay?
is,
A cosine 0 is what?
yeah.
It's 1. Sine 0. Cosine is 1, sine must be 0. Therefore, let's just remove them. You don't need angles. There's no angles here. See here? If you set up a coordinate system this way, x, this is positive, this is negative, right? For this vector, this is x component. What's the y component on this one? No y, right? Therefore, this is 0. What's the y component of this one?
Nothing.
No y, therefore y is 0. And what's the x component of this? It is itself, right? And what's the magnitude of this one? Oh, it is itself. Q, negative, I'm sorry.
Yeah.
Negative q, e negative q. But look at the direction. You said this is positive, therefore this guy
So we need a
is negative. Therefore, you have to put down negative sign. And see, everything is easy. Finally, you have EQ minus E negative Q times I. That's your solution. Oh, now you just need to spend some time on the scratch paper. That's why you need a lot of scratch paper. You need to do something beyond your worksheet. Okay, EQ equals what?
EQ equals 4.
The formula is here. K times
Oh.
Q divided by R squared. Okay, what is R? For E positive Q. The R is basically this distance, right? What is this distance?
R plus 1/2 K. A.
Yes. R plus 1/2 A. Therefore, you have R plus 1/2 A squared. That is E positive Q. What is E negative Q? Still K times Q divided another distance, which is this distance, right? What is it?
minus
We already labeled it.
R minus 1/2.
A.
R minus 1/2 A. Okay, look at these two expressions. Is this number large or this number large? Which one is larger? Numerators are the same. This is larger than this, right? Therefore, which is larger? Top one,
The
bottom
bottom
one. This is larger because the denominator is smaller. Okay. All right, just go forward, put them down. Therefore, you have KQ over R plus 1/2 A squared minus KQ divided by R minus 1/2 A squared. Then the whole thing inside the square bracket multiply the direction sign. Are you okay with this solution?
I know that you are not.
Cancel? What is cancel? No, nothing cancel. The thing is, you have to merge these two terms together, right? If I were you, I would write down an equal sign here and don't touch it at all. I get a big scratch paper. I just work on merge these two terms together. And the KQ, you don't have to worry about it. Both carries these. Basically what you have is this one minus this one, right? The thing is how to combine these two together. A lot of math, right? But I don't want to do it over here. I'll leave it for you.
Okay.
Next time, you let me know what's your solution of this mathematical calculation. Okay? Therefore, I just want one thing here next time with the direction sign I.
This is all our homework? Is this the?
You
No.
hope?
This is bonus
No.
homework.
You have other homeworks.
Quick question, where did the R come from on the positive EQ? Where did all that?
You want this distance for this cube, right?
Mhm.
That's how far this charge from this point.
Mhm.
This is R, what is this?
Right. I'm just
1
trying-
half A. Therefore, total distance is R plus 1 half A.
Oh, okay.
Got it?
Yeah, I see it now.
In this equation, this R must be the distance between the source and the point you are interested. Okay? Again, you are the boss. If you label those distances differently, the solution will be differently. Okay? But either way, it's fine. All right, so.